In this video, we are going to talk about rational zero theorem. Let P of x equals an x n plus an minus 1 x n minus 1 plus a2 x2 plus a1 x plus a0. As you know, an is called the leading coefficient, and a0 is called the constant. If P over Q is a root of P of x, then P is a divisor of a0 and Q is a divisor of an. To prove this, we use the fact that the value of P over Q is 0, and 0 is the multiple of any number. If we plug in P over Q into the equation, we find an Pn over Qn plus an minus 1 P to the power of n minus 1 over Q to the power of n minus 1 plus a1 times P over Q plus a0 equals 0. By multiplying both sides of this equation by Q to the power of n, we have an Pn plus an minus 1 Pn minus 1 Q plus a1 P times Q to the power of n minus 1 plus a0 Qn equals 0. We look at this equation in two ways. If we consider all the terms except a0 Qn, you'll see all of them is multiple of P. We take this to the other side, we'll see a0 Qn is multiple of P. With the assumption that P over Q is the simplest form of the root, we'll see P is dividing a0 times Qn. Since P and Q are relatively prime, P must be a divisor of a0. Similarly, if we look at all the terms except a and Pn, we'll see all of them are multiple of Q. If we take it to the other side, an Pn is multiple of Q. Since Q divides AN and P and Q are relatively prime, then Q must be the divisor of AN. As an example, we say if this equation this polynomial has any rational root, P must be a divisor of 1 and Q must be a divisor of 8. That means if there is any rational root, it must be one of these: plus minus 1 over 1, plus minus 1 over 2, plus minus 1 over 4, or plus minus 1 over 8. Thank you.